Hello, everyone, and welcome to today's webinar on migrating from self-managed Kubernetes to EKS. I'm Mateen Raza, a containers go-to-market specialist, and I'm joined by Aaron Miller, a container specialist solutions architect. Here's what we'll discuss today. I'll start with an overview of Kubernetes on AWS, talk a little bit about Amazon EKS, and why our customers choose Amazon EKS to deploy production workloads on Kubernetes. I'll walk through a few examples of customers who've successfully migrated to EKS and realized the operational benefits from having a managed service like EKS handle the complex, undifferentiated heavy lifting of Kubernetes. I'll then hand it over to Aaron, who'll walk you through some of the key considerations and best practices from our experience helping customers migrate to EKS. And we'll share available resources and we'll summarize on what we've covered in our presentation today. So before we get started, let's take a step back. Kubernetes is an open source container orchestration framework. It's backed and governed by the Cloud Native Computing Foundation, or the CNCF. Over the last few years, it's gained broad adoption and seen rapid growth. In a recent 2020 survey by the CNCF, 83% of respondents reported running Kubernetes in production today. It integrates all the key components for networking, storage, and compute that enable enterprises to run containerized workloads at large production scale. And as the adoption of Kubernetes has grown, so does the ecosystem of tools around it. In many cases, we find customers have chosen Kubernetes to take advantage of this rich ecosystem of open source and third-party ISV tools around Kubernetes. However, running and managing Kubernetes at scale can be challenging. There's a lot that needs to be done to configure for high availability, ensure that your workloads have the right security posture, the deployment can scale to meet variable user demand. Users and customers have to plan for failure and disaster recovery. And we found that enterprises who self-manage Kubernetes can end up spending a lot of time on this undifferentiated heavy lifting that's not related to the core business applications, but rather something that they need to continue to do to keep operations running. And this is why we built Amazon EKS. Amazon EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. And as customers move larger portions of their workloads to Kubernetes, we are meeting their demands with Amazon EKS. I want to highlight a few key attributes that our customers have come to appreciate about Amazon EKS. Firstly, we do not modify open source Kubernetes. EKS is fully upstream certified and conformant version of Kubernetes. We even backport security fixes into the open source version of Kubernetes to make sure we are consistent with the open source version. We support upstream versions for a longer period of time. We support up to 4 versions of Kubernetes, which gives our customers sufficient time to roll out upgrades. And as part of this support, we even backport patches, fixes, and upgrades to Kubernetes versions, even the ones that the community may not currently support. And our goal is to provide a managed Kubernetes experience where we do all of the work to select the right version of Kubernetes, validate dependencies, and provide the security, stability, and operational excellence that our customers rely on AWS to deliver. And lastly, our goal with EKS is to reduce the complexity of Kubernetes operations. So to summarize, what Amazon EKS provides and what we strive to provide with Amazon EKS is a managed experience with Kubernetes. And we want to ensure that with EKS, our customers get the best experience of running Kubernetes for their applications. Today, we have hundreds of thousands of customers using Amazon EKS who've used more than 1 billion compute hours on Amazon EKS. Whether it is travel companies like Skyscanner, social apps like Snapchat, or ISVs such as New Relic, all of these companies are transforming their operations with containers and with Kubernetes, leveraging Amazon EKS. All of our customers are driving important innovations and addressing critical needs using Amazon EKS. Here are a few examples of customers who've chosen Amazon EKS. HSBC, one of the world's largest banks operating in a regulated environment, has chosen Amazon EKS and trusts Amazon EKS for their mission critical applications. Similarly, Lyft's Level 5 autonomous vehicles use petabytes of data gathered from its AV fleet to run millions of compute intensive simulations each year to improve the performance and safety of its self driving system. This team has chosen Amazon EKS with EC2 Spot instances to boost its compute capacity and lower costs of compute. So let's talk a little bit about why our customers are choosing Amazon EKS. Teams choose Kubernetes for its vibrant ecosystem and community. It provides a consistent set of open source APIs and broad flexibility to use a variety of different tools and services that are present in the Kubernetes ecosystem. Customers choose Kubernetes for those reasons that I mentioned, and they rely on Amazon EKS to handle the undifferentiated heavy lifting of securely operating Kubernetes at scale. And customers who've adopted EKS get the flexibility of a widely adopted open source project with the experience and reliability that comes with a managed AWS service. Similar to customers such as HSBC and Lyft, EKS customers are able to reduce operational overhead, reduce cost, and de-risk their application deployments by leveraging the global scale and reliability of AWS infrastructure. Most importantly, for customers migrating off a self-managed Kubernetes platform, the applications do not need to be re-architected. EKS is fully upstream Kubernetes. So if it works on Kubernetes, it works with EKS. Now, I'm going to take a step back and look at the journey that EKS has been on, where we are today. Our goal with EKS has been to provide our customers the best experience with running Kubernetes. We started off when we launched the EKS control plane, where we manage a highly available, secure, and resilient control plane on behalf of our customers. We heard from our customers that they wanted us to manage more of the complexity around worker nodes with Kubernetes. So we added two options for worker nodes. One was manage node groups, where we extended the EKS API to manage Kubernetes worker nodes on EC2 instances in customers' VPCs. And the other option was EKS on Fargate, where we provide a serverless compute option for EKS. This really laid the groundwork to provide a fully managed Kubernetes experience for our customers, where we take care of everything from security patches to version updates to operational tooling within your cluster. And we intend to continue on this journey to provide a fully managed experience for the entire cluster lifecycle. This next phase is what we are referring to as cluster ops, where we will manage and deploy and operate on behalf of our customers operational software and add-ons necessary to support production Kubernetes deployments. We announced EKS add-ons in December last year, and VPC CNI is the first add-on that we'll be supporting. We plan to extend the support over this year and the next. kubeproxy and core BNS are the first add-ons that you'll see coming through after VPC CNI. In addition, other common tools for observability, scaling, management, and security will be coming shortly. Now, I talked about managed node groups, the managed control plane, and I want to double click into some of these before I hand it over to Aaron. Let's talk about the managed control plane. Now, managing a highly available, reliable, and durable control plane is one of the primary and most important challenges when operating Kubernetes at scale. The EKS control plane is designed with AWS best practices for security, scalability, isolation of failure domain, and fault tolerance. When you create a cluster with Amazon EKS, we deploy and manage an isolated single-tenant control plane on your behalf. It is designed to be highly available, durable, and reliable. We stand behind this with a 99.95% service level agreement for control plane uptime. Our engineering teams monitor alerts, and ensure that we meet the SLAs that we've guaranteed our customers. Secondly, EKS is, as I mentioned earlier, native and upstream conformant Kubernetes. Customers who leverage EKS can choose from a broad range of integration with tools from a rich ecosystem of Kubernetes. On the other hand, EKS seamlessly integrates with AWS native services. You can ship logs to CloudWatch, configure alerts, choose your ingress with AWS Load Balancer controller, and implement security and access controls with integrations to IAM and other AWS security and encryption services, such as KMS. In addition, customers operating in regulated industries or customers who are serving their customers who operate in regulated industries can leverage the work that AWS does to ensure that Amazon EKS is compliant with several industry standards, including FedRAMP high and moderate baselines, and several others, including HIPAA. Now let's double click into how Amazon EKS provides capacity for you to run your applications with EKS. On the worker node side, we have three different options for users to provide capacity to their applications. The first is self-managed node groups. Customers who prefer to manage their own node pools to provide capacity for their workloads can do so. They would just have to bring their own auto-scaling groups, running their own custom AMI, and then customers would be responsible for ongoing maintenance and patching of the underlying OS that they use for their managed node groups. With managed node groups, EKS handles the lifecycle of worker nodes on your clusters. Your worker nodes are provisioned by EKS in your VPC. They run the latest EKS optimized AMIs. When a new AMI is available, customers can initiate automatic draining and rolling out of new AMIs. Managed node groups also makes it easier to use AWS compute optimized instances such as Spot, Graviton, ARM, GPU-based nodes, Inferentia, and more. Furthermore, use of Nitro-based instances enable higher density and larger scale deployments. Fargate is the serverless compute option to provide capacity for your workloads. With Fargate, AWS runs the containers in our managed VPC. Customers do not have to manage any compute for their workloads. The pods are right size for your workload, and patching is fully managed. Let's talk a little more about the different instance types that are supported with Amazon EKS. Amazon EKS makes it easier to leverage a variety of different compute options for your workloads. GPU-based instances are very popular with customers who run compute-intensive machine learning workloads. Nitro-based instances enable security features such as security groups for pods, where you can apply fine-grained access controls between services at the pod level. Customers can further choose to optimize price performance with AMD or Graviton-based instances. Integration with Spot allows users to further optimize cost and leverage heavily discounted compute capacity. Now let's talk a little bit more about some of the key attributes of managed node groups with EKS. Managed node groups automates the lifecycle of nodes in your EKS cluster. If you use an EKS optimized AMI, AWS will notify you when a new version is available, and you can patch the AMI for your node groups in your cluster. Managed node groups also automates the health checks for your nodes in the cluster and provides alerts to the console or through CloudWatch. Users have the flexibility to ship these alerts and logs to any other open source or third-party tool. One of the key benefits of using managed node groups is the automated cluster updates, where AWS automation does a rolling update of the AMIs. And the process is indicated in this image below here. When the customer initiates a managed node group update, the size of the ASG is bumped by 1. Then each node is cordoned and drained until all the nodes are updated. And we're working on additional features to speed up this upgrade process by allowing more than one node to be updated or having a set of nodes to be updated in parallel. Now let's talk about Amazon EKS on Fargate. I want to remind our viewers that this is not a custom or proprietary implementation on top of Kubernetes. Customers who typically adopt Fargate do so because they like the security posture they get with Fargate, especially the VM level isolation. In addition, they also appreciate that they do not have to worry about bin packing and managing the utilization of nodes in the cluster. Fargate pods can be right-sized to meet the workload's requirements. Now, we also have to understand that Fargate is a different deployment model with EKS. Your application is still deployed using Kubernetes native APIs. Users will define a namespace for your Fargate profile, and any pods that are deployed to that namespace would be deployed using Fargate. But given the serverless deployment model, there are a few key considerations. For instance, daemon sets are not supported. So users who are using logging or monitoring tools that run as daemon sets will have to implement these as sidecars. Fargate does support fluent bit-based logging through a sidecar with a container. We also do not support the execution of containers as privileged containers. GPUs are not supported today, but this is something that we're working on enabling with Fargate. Now, before I hand it over to Aaron, I want to talk about a customer who recently moved to EKS and talk about New Relic. For New Relic, the move to EKS was part of a broader migration from their data centers to AWS. New Relic now ingests almost 90% of its customer data on Amazon EKS clusters. And right now, they are nicely set up to meet the demands of their growing customer base. Not having to self-manage Kubernetes saves the New Relic ops team over 10% of its time. This allows the team to focus on its core competencies. They release products faster, improve the user experience, and overall create more value for their end customers. With that, I'm going to hand it over to Aaron to double-click into some of the best practices that we've observed as customers migrate to EKS.
Thanks, Mateen. My name is Aaron Miller, and I'm a container specialist solutions architect, and I'm going to talk to you about best practices when migrating your Kubernetes workloads to Amazon EKS. We're going to focus on 4 main areas today. The first of which is security. We'll talk about how to implement least privilege and enforce separation of duties. Network planning and design is critical for a successful deployment. So we'll also discuss the most important networking items to consider when planning a migration to EKS. For those that are migrating stateful workloads, we'll cover how to integrate into native AWS storage solutions. Finally, we'll talk about best practices to automate the deployment and how to leverage infrastructure as code tooling. First, let's start with the EKS control plane. Since this is a migration webinar and you've already built a Kubernetes control plane, you already know how complicated this can be. With EKS, it's simple. The Kubernetes control plane is fully managed. It's highly available and reliable by default. And since it's completely automated and managed by AWS, you may want to understand more how this compares to what you already have in your own environment. First, EKS runs the control plane components across multiple availability zones. This contributes to its high reliability, and additionally, the control plane is also self-healing. So EKS will automatically detect and replace unhealthy components or nodes. As you can see in this diagram, etcd is deployed separately from the rest of the control plane components, and they each have their own auto-scaling group. As your workload changes, EKS automatically scales the control plane instances based on load. Also, when you create an EKS cluster, you get your own dedicated control plane. This is dedicated single tenant infrastructure. The last thing I want to cover here is around security. Your control plane is kept secure. EKS will automatically apply the latest security patches to your cluster's control plane without requiring any downtime. I want to talk a little bit about networking considerations and some security best practices when you create the control plane. This diagram shows the networking layout of an EKS cluster with the AWS managed components on the right in your VPC on the left. You can see the EKS API and Fargate pods have their network adapters placed in your VPC. When you create an EKS cluster, you need to assign 2 subnets. And this is where those EKS created network interfaces will be placed. They're used for the control plane to communicate to your nodes. So when you run commands like kubectl exec and kubectl locks. Our recommendation is to create 2 small subnets. You can do this with a /28 CIDR. This will give you much more flexibility when creating and managing the rest of your subnets for your worker nodes and load balancers. We also recommend limiting access to the control plane. You can do this by making the cluster API endpoint private. When it's private, it can only be accessed through the VPC or a connected network. Alternatively, if you want the endpoint to be public, so this means it's accessible over the internet, you can restrict access to certain CIDR blocks. Lastly, we're going to recommend that you enable control plane logging. So this includes logs for the API server, scheduler, controller manager, and also very importantly, the audit log. And the audit log is critical from a security standpoint. It can identify which users or system services made specific API calls to your control plane. Next, let's talk about authentication. There are 2 ways to authenticate to an EKS cluster. The primary mechanism is to authenticate to EKS through integration with AWS's Identity and Access Management, or IAM. I want to make you aware of the other authentication method, which is OIDC, and that stands for OpenID Connect. This lets you connect to an external identity provider. If you choose to use OIDC, there isn't anything EKS specific once you enable it. But since IAM authentication is unique to EKS, and it's the mechanism that's most often used, we're going to focus on it today, as this will be critical to a successful migration. So let's explain how authentication works. The process is outlined in detail on the slide here. It starts when you run a command like kubectl get nodes. The kube config is set up to use the AWS CLI and sends a token to the EKS API server. There's an authentication webhook that validates the token with AWS IAM. Once validated, the API server determines if you are authorized to perform the command. And we'll talk about that next, how we move from authentication to authorization. Management of users and authentication is done with a config map that we call the AWS Auth config map. I have an example config map on the slide to show you what it looks like. This is how we securely map IAM users and IAM roles to Kubernetes users and Kubernetes groups. Authentication is separate from authorization. Authentication is handled by IAM. IAM will identify who you are through an IAM user or an IAM role. Authorization, on the other hand, is handled by Kubernetes role-based access control, and it's managed through Kubernetes roles and role bindings. One other important thing is that the auth config map isn't just for users, it's also used for authentication of your Kubernetes nodes. And that's what you can see in the example on this slide. This will be set up for you automatically if you use the EKS CLI to create your cluster. So under the area that says role ARN, it will populate the IAM role assigned to your nodes, and it will map those to 2 Kubernetes groups, system bootstrappers and system nodes. Typically, you will have an entry here for every node group that you create. So we've seen how we can configure authentication for nodes, but what about users? So let's talk about that next. The example on the slide here shows 3 IAM roles that map to the Kubernetes predefined admin, power user, and read-only cluster roles. Note that this example uses IAM roles, so your users would have to assume a role. If you'd like, you can directly assign this to IAM users. Just remember that your 2 options are IAM users or IAM roles. IAM groups are not a valid option. The next security best practice that we're going to cover is IAM roles for service accounts. You'll often see this abbreviated as IRSA. And this is how we enable least privilege and separation of duties in an EKS environment. To understand why this is important, let's walk through a scenario without IAM roles for service accounts. Let's say, for example, we have an application running in our Kubernetes cluster that needs access to an S3 bucket. To enable this access, we would add the S3 access policy to the IAM role that's assigned to every Kubernetes node in the group. This would mean that all the other applications running on those nodes would also be able to access S3, even if they didn't need it. And this would violate our least access principle. So this is why we use IAM roles for service accounts. Here we assign minimal permissions to the EKS nodes. This usually includes 2 IAM policies, the EKS worker node policy and the Elastic Container Registry read-only policy. The last one is so that nodes can pull container images. Then, with IAM roles for service accounts, we can assign the S3 access to just the pods that need it. And that's what's illustrated on this slide. So IAM roles for service accounts allows us to scope permissions to pods, and we don't share credentials between pods or between the pods and the nodes. So how do we set this up? There are 3 main steps. First, you need to create an IAM OIDC identity provider for your cluster. This is done just once. So you can automate this in your cluster build out, and we'll talk more about that later. Second, you create an IAM role and policy for your service account. And this is done each time you need to enable least privilege access to a Kubernetes service account. In our example, this would be an IAM role and policy for S3 access. And then third, you annotate the service account with the IAM role. And that's it. When you deploy your application, EKS will automatically inject the credentials into your pods. So let's pivot and talk a little bit about networking now. Networking in Kubernetes is enabled through the use of plugins that leverage the Container Networking Initiative, or CNI project. There are many that you can choose from. And if you're looking to migrate to EKS, you've likely had some exposure to one or more of those. For EKS, AWS has developed a VPC native plugin called the Amazon VPC CNI, and it makes pods first-class citizens inside the VPC. There is no overlay network. What that means is that all traffic flows between nodes directly on the VPC network, and you can leverage all the VPC features and functions just like any other traffic. So how can you use the VPC CNI? EKS has a feature called Managed Add-ons that Mathine talked about earlier, and that can deploy the VPC CNI for you. Managed add-ons will also assist with lifecycle management, and it makes upgrades even easier. Of course, if you'd like more control, you can deploy the VPC CNI yourself after the cluster is created. One last thing I want to cover here is if you want additional security in your network, you can enable Kubernetes network policy. In EKS clusters, this is done by installing the Calico network policy on top of the VPC CNI. This will allow you to provide policies that allow or restrict access between certain pods based upon namespaces and labels. Many of our customers enable an advanced feature of the VPC CNI called custom networking. So why might you want to use this? Migrating from another Kubernetes environment, you may be familiar with overlay networking. One of the benefits of CNI plugins that use overlay networks is the ability to use a pod network that's completely separate from your host network. And that's what's illustrated on this slide. The host is on the 10.1 network, while the pods are on the 100.64 network. And this can be really beneficial when you have limited access space. Sometimes this is the case if you use Direct Connect or VPN to an existing on-prem environment. If you decide to use custom networking, you get a private, dedicated pod network, but it does it without any encapsulation. The extra network is enabled by adding a secondary CIDR to your VPC. There's also some additional configuration required for the VPC CNI. Also, with custom networking, pods are still first-class citizens. They just use a separate network. Let's continue the conversation around networking and talk a little bit about how we can expose our applications outside the cluster. Kubernetes has a native object called the Kubernetes service, and it allows inbound traffic to reach your applications. When you create a service of type load balancer, the cloud controller built into Kubernetes, also called the in-tree controller, will create a classic load balancer by default. If you look at the diagram, the way the traffic flow is it flows from the load balancer to the EC2 instance, and kubeproxy will route traffic to one of the ready pods backed by the service. AWS best practices are to use the newer network load balancer, NLB, and application load balancer, ALB, when possible. The recommended way to utilize these newer load balancers is to install and configure the AWS load balancer controller. So let's talk about that next. First, a little background. The AWS load balancer controller is version 2 of a project that used to be called the ALB ingress controller. So if you see any reference in older materials or blogs to the ALB ingress controller, you can rest assured it's referring to the same project. You may also be aware that network load balancers support 2 target types, instance mode and IP mode. Let's talk about what those are. Instance mode is the same traffic model that we just discussed, the one used by the classic load balancer. Traffic flows from the load balancer to the EC2 instance and then through kubeproxy to the pod. The one thing I want to highlight, and it's also a best practice recommendation, the AWS load balancer controller also supports another target type for NLB, and that's IP mode. This is where traffic is routed directly from the load balancer to the pod. If you look at the diagram on this slide, you'll notice this is different from the previous traffic flow with the classic load balancer. Instead of traffic going from the load balancer to the EC2 instance and then to the pod, traffic goes direct from the load balancer to the pod. This is possible because the VPC CNI that we discussed earlier makes pods directly accessible on the VPC network. There are a few benefits from using IP mode. IP mode decreases latency and it improves scalability. It can also result in smaller target groups if you have a large cluster, and this can really help reduce management complexity. IP mode is enabled through an annotation on the service, and it's illustrated on the slide in yellow in the top left. This is where you can see load balancer type as NLB-IP. Another way to expose applications outside the cluster is through Kubernetes ingress objects. Ingress is designed for web applications. So this is HTTP, HTTPS, and it allows for host and path-based routing. Application load balancers can be used to perform that routing. The AWS load balancer controller configures the ALB's listener, rules, and targets to enable this. Another really important point is that a single ALB can support multiple ingress objects. So ALBs have a service quota of 100 rules per load balancer. Those rules are used to perform the routing, and it's how a single ALB can support dozens of ingress objects. Like the networking load balancer, ALBs also have the option of the 2 target types, instance mode and IP mode. The same benefits that we talked about with IP mode for NLB also apply to IP mode when you're using ALB. And we recommend that you consider IP mode for your ingress application. So with the AWS load balancer controller installed in your cluster, all that's required to use an ALB for your ingress is just to annotate your ingress object with kubernetes.io/ingress class ALB. And that's illustrated in the top left of this slide. Customers looking to migrate stateful applications to EKS will want to investigate the use of CSI drivers listed on the slide here. First, a little background on CSI. The Container Storage Interface, or CSI, is a standard for exposing block and file storage to containerized applications on Kubernetes. Using CSI, customers can deploy storage plugins to expose additional storage systems in Kubernetes. EKS has plugins today for 3 common AWS storage systems: Amazon EBS for block storage, Amazon EFS for file storage, and Amazon FSx for Lustre. If you have a stateful application that you'd like to deploy on an EKS cluster, you can deploy these controllers using the instructions in the EKS documentation. Our final topic today in best practices is on cluster operations tooling. One of the most important things you can do to ensure a successful migration is to test the cluster build-out and deployment of your applications in your EKS cluster. One of the best practices for this is to use infrastructure as code. In AWS, the native infrastructure as code tooling is AWS CloudFormation. And while we offer CloudFormation templates that you can use to build out new EKS clusters, the easiest way to get started is with eksctl, the official CLI for EKS. eksctl still uses CloudFormation behind the scenes as well. It just makes it really easy to use with a simple CLI. Another option is the AWS Cloud Development Kit, or CDK. If you haven't already heard about it, the CDK is a software development framework for defining cloud infrastructure in code. Like the EKS CLI, it also uses CloudFormation. The CDK allows you to define reusable cloud components that we call constructs. And it comes with a construct library that can help you quickly define multi-service solutions using well-architected patterns. This can save you a lot of time as you build out your cloud environment. Finally, because the EKS API is open and documented, and because EKS runs certified conformant Kubernetes, you are free to use third-party infrastructure as code tooling as well, if it best meets your needs. I mentioned earlier that eksctl is the easiest way to get started for new EKS customers. One of the reasons why is because you can create a VPC, all of the networking configuration and dependencies, and a working cluster with a single command, eksctl create cluster. When you run that command, eksctl will create a CloudFormation template and deploy it to AWS, so you're still using infrastructure as code tooling. Additionally, eksctl supports a cluster configuration file format, so you can use that file as your declarative infrastructure as code cluster definition. Some other benefits of eksctl are the ability to run utility commands. We discussed earlier, one of the best practices was to enable IAM roles for service accounts. That requires setting up an IAM OIDC provider for your cluster. And with eksctl, it can be done easily with a single command. Lastly, eksctl makes it easy to adopt GitOps and configure a Flux-enabled GitOps controller in your cluster. For those new to the term, GitOps is a way to do continuous delivery. It works by using Git as the single source of truth for your entire Kubernetes cluster. So when your DevOps teams do deployments, they will use a Git push or open a pull request instead of running the kubectl apply command directly. A really exciting open source project that we are working on is called CDKs. This is based on the design concepts and technologies of the AWS Cloud Development Kit that I discussed earlier. The problem this is trying to solve is that a lot of application deployment on Kubernetes involves writing significant amounts of YAML. And ultimately, there's a good amount of work involved in writing those boilerplate configuration, applying customizations, and also trying to ensure best practices and standards. This is the exact same problem we're working to solve when it comes to CloudFormation and the top-level CDK project. So CDK8 uses the same design concepts and technologies as CDK, and it lets you define Kubernetes applications and reusable components using familiar programming languages like TypeScript, Python, and Java. CDK8 greatly helps simplify the process of defining a Kubernetes application and all of its components. Once you have defined your application in CDK8, the output is still just plain YAML. So you would perform a kubectl apply, or in production, likely use CI/CD tooling or a GitOps workflow. I do want to highlight the project is still under active development and it's currently in beta, so keep an eye on it as it approaches a GA release. As you continue on your migration journey, there are a number of resources that we have included on this slide. I'd like to highlight two of these. The first is the EKS workshop. This is a great way to get familiar with EKS and walk through a number of configuration scenarios and some of the best practices we've discussed. Also, I'd highly recommend you review the EKS Best Practices Guide. All the best practices we discussed today and many more are included in that guide. And it's constantly updated, so it always has the most current information. With that, I'd like to hand it back to Mateen.
Thanks, Aaron. As the next step, I would like to invite you to a workshop, or immersion day, or a classroom-based instructor-led training to help you ramp up and get familiar with Amazon EKS. As Aaron mentioned, the Amazon EKS workshop is great. It's a self-guided, hands-on workshop that you can take in a self-paced manner. On the other hand, the immersion day is when you have a guided day of containers experts walking you through some of the different configuration options that you have with Amazon EKS. Amazon EKS training is an instructor-led training for teams that are ramping up on EKS or Kubernetes. So I encourage you to take advantage of these services that we have, these training programs that we have, and continue on your journey with Amazon EKS. With that, we'll open it up for Q&A.